the recording start. Once you're in the recording mode, I'll start it. Yes. Yeah. Just one confirmation. Anybody? Visible and screen is visible and am I audible? Screen visible and am I audible? Just any one of you in the chat box for me. Yes. Thank you. Thank you. Okay. Yeah. We'll continue. Okay. So see, in the yesterday's class, we were discussing about the daemon processes, right? So we know what is a daemon process now. The processes which run continuously at the backend are known as daemon processes. And we also know now they don't have a controlling terminal, nor they can be in the control of user. And they always run at the background only. And when a daemon starts, it starts when you start your system, and a daemon stops when you shut down your system. This was what we studied. We studied about the characteristics also of daemon. What a daemon here. I'll just go back again here. Just do a highlight. Daemon characteristics. Daemon runs in the background. Yes. Daemon the super user privileges so that no other process should harm it. Daemons don't have controlling terminal. As I told you, in Windows as we have Alt Control Delete, which will stop the process. Here we don't have controlling terminals. And daemons becomes a session and group leader. Just a minute, I'll just stop. With which they become the session and group leader, because once a daemon runs, no other process should stop it, neither the parent daemon. So this is what we studied in the previous classes. Then we studied about these characteristics in detail, what each daemon does. Then we studied this was in the previous classes. Coding rules are like now, once you know what is daemon, how can you create a daemon now? Maybe the next question arises in your mind is, how should I create a daemon process? So there are some rules to be followed when you're going for creating a daemon process. The first rule is call fork and have the parent exit. That means the minute you create a child process by the fork system call, stop the parent, then call the umask. As I said, umask is to remove the default file permissions, that is read, write and execute permissions which are given, right? You should remove all those permissions from that process. After that, call set SID, that is the child which is running will become the session leader and become the process group leader and has no controlling terminal because everything is removed from it. And make sure that this daemon runs in the root directory, that is change the current working directory to root directory. Then close the unneeded file descriptors, that is the standard input, standard output and standard error should be closed for the process. Then close the file descriptors 0, 1, 2, that is init process, standard input and standard output, which are to be closed by the user. And this is what we studied in the previous class. And one more thing which I told yesterday also, you should again call one more system call, which is nothing but the signal. Now signal sig hub, that means hang the signal which is trying to interrupt this process. How can I do that? By the system called signal. That means if any signal tries to stop this process, that signal should be hanged up. It should not be allowed to stop the process. So once you run this entire code, this is nothing but your daemon process. That is what we studied in the previous class. Then this was a sample code which I showed you, like a sample daemon how you can run in your system also, without any controlling terminal, nothing. Just run it and just see how exactly it works. This was what we studied in the previous class. Then we studied about the error logging, very important as I said. Since daemons don't have a controlling terminal, how to handle error messages in daemon becomes the next important question, right? Because daemons don't have controlling terminal, there is no input, no output, no terminal only for it to run, right? Then if error occurs, how the daemons will handle the error messages? One thing is they can write onto the console. They can write to the standard error file also. But since they don't have the control terminal, it can't be written to the error file. If at all you want to write to the console device, but what happens here is, since daemon is running on n number of systems, if n number of systems are there, on each system you should give a separate daemon file. So what happens there is on each system, you should execute it separately, right to the console. So assume that if there are 100 systems connected to you and you want to write an error message, so I should write that error message onto the 100 devices on which the daemon is running. So this is also a tedious job. So what we can do here is there should be a central daemon error logging facility is required. So if at the central level only there is a daemon logging facility available, then whatever the errors are encountered in daemons can be resolved for us. Okay, so that is what a error logging facility. So in that, Unix provides two ways of error logging facility. One is SVR4 and the other one is 4.3 BSD logging. So these are the two centrally designed mechanisms which can control the errors in daemon processes. We can control the errors in daemon processes. So the first one, see in the exams if they ask, explain the error logging facility in daemons. If it is asked for 10 marks, then you should explain both SVR4 as well as 4.3 BSD log files. But if they ask explicitly, explain the SVR4 error logging mechanism, then only one is sufficient. Okay. So what is this mechanism here? The diagram I'll show you. So what happens here is, what does the kernel do is, kernel reads all the error messages from str log file. Now there is a log file in the systems by which a kernel keeps on reading all the information. How it can happen? The error may generate from the user. Either the user can write it onto the device console log, or the user process can send a put message system call to the /dev/log file. So what happens is all this log device drivers which are reading it from the user process are kept here. So there are two ways. One is how can you generate the log messages, and the other one is how you can read the log messages. Now read the log message means if any error occurs, how the errors are generated, and once the errors are generated, how the errors are read, because since there is no console available for us, as I told in the previous class. So what happens is the log message generation in SVR4, it can be kernel routine can call str log file. Now there are n number of drivers in the systems available for me. So what does the kernel do is it calls the str log file. Now what is the function? Its function is to generate the log messages. And what they can do, either these modules are stream device drivers for either error messages or trace messages. So what they do is they read it from the str log file. So now when a user process, that a user daemon is running, now this is from the kernel daemon. So kernel itself can write a daemon process which is at the system level. User itself also can create a daemon process. So here user also can write its daemon process. It can write all the messages to /dev/console log. So what happens here is either user can write it or user can call the system call. User can call the system call put messages which can write to /dev/log file. So kernel can read it from str log, whereas the kernel daemons, whereas the user daemons can generate it the log messages by either writing to /dev/console log or /dev/log. Now all these messages are kept here. Kernel has read all these messages and it is kept at the system level. Now the next task of the kernel is, once all the error messages are coming at the central level, now the next task of the kernel is to give it to the respective loggers so that they can get the error messages or they can read the error messages from those loggers. In that way there are three loggers. One is error logger, the other one is a trace logger, and the third one is the console logger. So what does it do here is, if at all the error messages which are generated, it has to be sent it to the error logger. That means there is a log file which maintains the list of all the errors. So once a error logger here, it can send it to /dev/log file. In that it will call the system call get message, which will give the error message to the standard error strerr. That is nothing but the standard error which is generated by the system. So only whenever any error occurs, the system generated errors are known as standard errors. not the error message which you printed. The system generated errors are known as standard errors, and they are maintained in a folder called /var/admin/stream driver/error.mm-dd, which indicates in which month and which day this error was generated, and you can read it from that. The second one is the kernel can send it to the strace logger. Now, what is a trace logger? This logger can read the error messages from the standard output, maybe on your monitor screen. See something, if Windows goes works abruptly for you, and when you start the system, suddenly a message comes on your screen. Your Windows was shut down because of this problem, right? So what is that message coming? The message is generated by the kernel to say that something went wrong with your system, and this is the error message generated. It will also send it to the error file. You should be maintaining the log file, so that next time when the same error occurs, what action it has to take. It will be maintaining the error file also, and also it will send it on the output screen. See on our laptops and all, right? Suddenly if system abruptly stops or restarts, you just get a message from Microsoft Windows. Your system was restarted because of this problem. So what is that? It's a trace message. Who generates that? Kernel generates it by the system called get message, and it will be displayed on the standard output. It also generates the error message and sends it to the error file. Apart from that, it also generates the error message and sends it on the standard output. Again, the kernel not only can send the information to the error file, not only send the information to the standard output, but also the kernel can send this information to the console logger. That means the information can be maintained in a file, which is we call as a log file, or it can be emailed to the respective user on which this error has occurred. So this is how the SVR4 will read the errors. It will read the error from kernel or from the user processes. Once the errors are gathered at the log stream device drivers, then the next task is, after generating, those errors are to be displayed also for reading purpose. So it will send it to the three loggers. One is the error logger, which is maintained in an error file, list of all the errors which encountered in your system. Next one is trace logger, which displays the output on the screen for you. And the last one is console logger, which maintains the information in a file or can be email, which is sent to the respective user. Now this happens, the daemon process error mechanism, on a single system. So if it is on a single system, this is how your errors are generated, and this is how your errors are read. So this is what happens for error logging mechanism facility on a single system. This is what is told here. Okay. The routines within the kernel call strlog to generate the log messages. They call that. So whatever went wrong are generated. They are the stream device drivers for either error messages or trace messages. So now what does the user process do, which is a daemon? It can put message to device log. So it will generate and it will put to the device loggers, and it will be sent to those three loggers. Again, a user process can write to /dev/console log. Now once user process can write to this console log, the message is sent only to the console logger. But if it is sent to /dev/log file, then it can be sent to all the three loggers. Now kernel decides that. If it is the user is putting in /dev/log file, then the error message sent to all the three loggers. But if the user generates the error message only in console logger, which means that it has to only send to this console logger only. It will not be displayed on the output screen nor into the error file. And reading it, again same thing. The normal errors are str, error, which we usually write in our program, right? Standard error, st error. Those are the standard errors generated by the system. And the trace logger, what does it do? It writes specified set of trace messages to the standard output. So whatever errors have occurred, those errors are taken and written onto the screen. And console logger is something like it will be maintained in a file, or maybe a doc file, text file, whichever format it is, or it will send an email to the certain users on which this error has occurred. Now this type of error logging facility is maintained for the systems which are only on the standalone machines, standalone systems. But what if the daemons are running in network? Yeah. See, please remember the variations also. SVR on a single system, and what if there are n number of systems connected with me, and n number of daemons are interacting with each other? Then how this error logging facility should be maintained? At that time, we use another error logging facility, which is called as 4.3 BSD system logger. Now, what does this 4.3 BSD logger do is, this will keep track of all the error logging facility in the network. Now, just now, Umesh sir took about networks, right? You know now FDP and UDP, yeah, user datagram packet and all, right? So what happens here is, whenever your systems are connected in a network, then how this error logging facility is maintained. So if you look at this, what happens here is, again there comes the two concepts: how to generate the error message and how to read the error message, or generate log messages and how to read the log messages. Now what does it happens here is, here on the single system was okay, this was working for me BSD, but what if n number of systems are connected and daemons are interacting with each other, and what if an error occurs? So what happens in this concept is, logging facility is, kernel reads the log messages from /dev/klog file. Now, if at all possible, I'll just show you here. But since I'm working on virtual machine, probably it may not. Yeah. I'll just show you how exactly this thing goes here for you. Okay, let it start. Division number. Just I'll show you. Yeah, because in this it is very difficult for me to get it on a virtual machine. Else I could have demonstrated here itself. So what happens here is, the kernel will in turn, for generating log message, what does the kernel do is, kernel calls a routine log. It calls a routine log. Now what does this message do is, it will read all the user processes from the file /dev/klog. So what happens is, whenever the systems are connected, kernel reads all the log messages from /dev/klog driver. What happens here is, because most of the user processes which are running, the user processes, they call the daemon syslog. Now what does the syslog do is, this is a log file which is generated by all the user processes. And now the user process which is connected to the host, what happens here is, they're connected to each other by TCP/IP model. So they can send their log message to the UDP port. So what happens here is, because n number of systems are connected, the kernel will generate all the log messages from /dev/klog by calling the system call log. So apart from this, the user processes which are connected to the network, they call the system called syslog. And what does they do? They write to /dev/log file. Now once they write here, since all the systems in this are connected with the TCP IP model, the user can read the error log messages from the UDP port 514. So this is how the errors are generated. And when it comes to the reading part, now errors, this user process generates from syslog, kernel generates from log, and are maintained at UDP port. They are maintained in syslog D. So since all this error messages are maintained in syslog D, now which system has generated the error message can be read by the UDP port 515. So what does this do is the syslog D daemon reads all this form of messages by reading and configuring syslog as confab file. So what does it happen here is this file runs in the system when you bootstrap the system. Now what I mean by bootstrap is a concept when you start the system. So the minute you start the system, this file which is running in the network, it keeps on running at the backend. It reads all the error messages either from the user process or from the kernel routines. This is example, like for example, if any urgent message wants to be sent to the system administrator, the user can send the file to this user datagram packets, then kernel will read from which packet it is coming and for which this message has to be sent, the error message, and kernel diverts that message to the respective host there. So the admin can directly read it from that port. Again, simple example of this see here now. The simple example of this is the WhatsApp group what we have now, right? Now everybody can post. Yeah, as you being an admin, you can keep on reading it from the WhatsApp group. N number of people are here. Now this user can put a message in the WhatsApp group. Now it is available in the WhatsApp group, but you can still privately reply to an individual person also, right? Reply privately. Now what it means reply privately is you're reading it. A user can read the message privately also or from the group also. Similarly, it happens in network also. So whenever any error is happening, the user process writes to those logger, and in that logger it will explicitly tell to which consoler the file has to be gone. The kernel reads it from the console by the UDP port, and from there it directly diverts that read message to that exclusively user only. This is how the error logging facility, because if you post in a network, whom will we understand it? See, if you post anything in the group also, happy birthday, if you post it, whom are you wishing it? True, because when there are 70 people in the group, you are just posting that. But if you post happy birthday at the rate and if you put their name, so you will exclusively understand that this message is for this user. See, relate the practicality. Yeah, if you just put a happy birthday message, to whom are you targeting that? But the same thing, if you write happy birthday and the person name, that means you'll clearly understand that this message is for this user, right? Same thing happens. This is the facility. So same thing, when an error occurs in a network, the user process writes that error message that this message has to be going to the network admin. But since n number of people are connected in the network, the kernel can read the messages from the UDP port and it diverts that message exclusively to that processor. So this is how the error logging facility is maintained by 4.3 BSD syslogger. That is what is explained here. Again, there are three ways to generate log messages. That is, kernel routine can call log function. So what does this do? This message can be read by any user process that open read and reads the /dev. So kernel routine can call this. Second one is the user processes. Again, the daemons which are running, they can generate for all these three log messages, and they can get it from the socket /dev/log file. And the third way is a user process on the host or some other host that is connected to with TCP IP. They can read the log message with UDP port 514. Now this is a port with which User can put it and read the information. So what does they do here is the syslogd daemon can read all these three forms of messages. Maybe the message from the kernel, there is an error message from the kernel, there is an error message from the user process on the same kernel, or there is a message or there is an error message from a user process on this host, running on this host. So the syslogd daemon reads all these three forms of log messages. So on the startup, the daemon reads this configuration file, which is given in /etc/syslog/conf, which determine which different class of messages are to be sent. So these are the three error messages. So which of the three different class of messages to be sent are read by the syslogd daemon. So once it reads it, then how it communicates it? Because once it does this, so after doing this, the system will read these messages with the help of syslogd, and it has to be sent to which three loggers, either to the console logger, to the trace logger, or to the error logger. Now this is how the BSD 4.3 central mechanism helps for generating and reading the error messages for daemon. Okay, any doubts here? Come back here. Any doubts here in error logging concept to be understood? The SVR4 is on a standalone machine. The BSD is on a network. No doubt, students? Okay. Come to the last concept here. So now if this is done, the last concept, which is nothing but the client server model. Now if you look at this, what is a client server model? Now we know now what is a client and what is a server concept, right? Server is one which is all time up. Clients, when a request is sent from the client, server responds, right? Same thing happens in nowadays now the data pack which you are using it, right? It's all time being recorded by the server for you. If at all you have a Airtel, Vodafone or Jio, whatever the data you are using from your mobile phone is keep on recording by the system app for you, right? So whenever you want, you process it, you will get the information. For example, in Airtel you have *123#, right? If you do that, it will show you, okay, 200 MB data is used. So after 5 minutes again, if you do that, it will show you 250 MB is used. Again after 5 minutes, if you do that, it will show you 300 or 350 MB is used. So what I mean to say here is, you are the client and the Airtel is your server. So what happens is, now what is the server doing there? It is keep on recording your day-to-day activities, right? So same way it happens in daemon process also, because maximum daemons are nothing but the server processes. Why? Because your activity should be right. For example, now the data pack what you have now, if you say the Geo, right? Whenever I want to know how much the balance I have used, anytime at the night also, if you just send a text message, directly you get an automated response there, right? So what is happening there? The process which is recording all your stuffs is nothing but a server process, right? So we know now what does a server do. It's a server process is nothing but a process which waits for client to contact it for requesting some type of services. That means whenever a client requests for a service, server has to give the response within no time. The mobile OTPs and all what you get now, right? So the minute you request, that suddenly OTP comes to your mobile phone, right? So what is happening? The process which is maintaining all the OTP is running all time. So it is when it is running all time and it is not in your control, we can call it as a daemon process. So daemon process is nothing but usually they are the server processes, because sir, you said it runs continuously. So a process which runs continuously usually becomes a daemon process, and most of the server processes are the daemon processes, right? So for example, if you look at this, if I talk technically, INETD, now this is a daemon which is running on your system that listens all the system networks interfaces for incoming requests from various network servers. So n number of network servers are connected, so it keeps on listening to the network interfaces for incoming request. Now this is a daemon which is running in your system all the time, which will help you to connect for n number of networks. And there is one more daemon process, that is sys log d. That is, this service provides logging of an error message. But anytime if your system goes down, suddenly an error message comes on your screen, right? How it comes? Because of this daemon which is running on the server. So the concept what we are studying here is client server model. Please remember, in client server model, we know now there is a client and there is a server who is responding to the client's request. So in that way, most of the daemon processes are nothing but the server processes. They keep track of user activity which is happening. I give the example of your Geo also now, right? At any time you text it, you get how much data is used, right? So what is happening? Your activity is being recorded continuously. So all those processes becomes a server process, right? So maximum, how can be a daemon process be used? Daemon processes are mostly used in client server communication. Please remember. So wherever you are getting an automated response within no time is nothing but a daemon process which is running at the backend for you. Please remember this. The OTP which is being generated for you is nothing but a daemon process which is running for you all time. All time. The minute you type a message *123# which is nothing but to check your balance or something, that process running at the backend. So please remember, daemon processes, the most use of daemon processes is in the client server communication. Okay. So what all we studied in this daemon unit? Like what are daemon processes? We studied they are the process which run in the background. They don't have controlling terminal. They're not in user control. Characteristics we studied, the 6 coding rules for daemons, and the error logging facility. SVR4 is a central level facility to maintain the errors on the standalone machines. 4.3 BSD is the error logging facility which is maintained on the network. Then we studied the client server model, which tells that maximum of the daemon processes are used in client server computing only. Why so? Because I gave the example. There are some processes which should be running continuously for you to keep track of your activities. Okay. So this completes the unit 4 for you, which is nothing but signals and daemons. Okay. Any doubts, students, here? This unit which we already studied. Any doubts in this unit? No doubts? So probably Monday you have a guest talk, which will be at 10 o'clock at the set time. Tuesday you don't have class, Wednesday you don't have a class. Thursday, Friday onwards your IAs are starting, so let your IA get over next week. After that, which will be meeting it on 10th, as I said. 10th will be your course seminar / project activity. So please keep a track of that. On 10th, everybody has to come up with their course seminar activities.